Hi, I'm Gregor Harich and I'm assistant professor at the IPD CAD Lab, University of Maribor. Additive manufacturing offers exciting possibilities for prosthetics. Especially 3D printing allows for personalized and cost-effective production. At the IPD CAD Lab at the University of Maribor, we are focused on advancing 3D printing for lower limb prostheses. For the evaluation, we need a novel test approach that goes well beyond the outdated ISO standard.
Hi, I'm David. I'm a master student at the Technical University of Munich. Currently, I'm here working at the University of Maribor at the evaluation of a prosthesis using a robotic system. With such a system, the strength and durability of prosthetic components should be evaluated. For testing a 3D printed prosthesis using an artificial limb and an industrial robot was utilized. In a first step, the desired trajectory was based on a downscale data from a walking lab. The force signal was used for monitoring failure. Here you can see that the test stops for irregularities. The D-Space platform is the heart of this approach. It sends the desired trajectory to the robot, and from the interface point it measures the forces which we can monitor then. One drawback of this approach is that it is based on a real gait cycle, so we can't adapt it for different body types. A promising approach for this is the real-time hybrid substructuring method. This approach was already investigated at the Chair of Applied Mechanics at the Technical University of Munich. Here in Maribor, we already took first steps into this direction, so we used the industrial robot for a very simple one-dimensional mass spring damper experiment. However, there are still a lot of research questions we have to tackle for using RTHS at gait cycle analysis.
In summary, our work represents a step forward in prosthetic evaluation and analysis. By combining robotics and innovative testing techniques, we are paving the way for more reliable and realistic assessments.